This is the 2011 FRQ number 4. All right. A continuous function f is defined on the interval between -4 and 3. The graph of f consists of two quarter circles. So this is a quarter circle and this is a quarter circle. Good to know. One nice segment. As shown in the figure above, that g equals 2x plus the integral of this. All right, so before you even start, this is very awesome that they give you this, right? It tells you that g of x is defined as 2x plus the integral between x 0 to x f of t dt, which means the g function is the area of this graph plus this 2x, right? G prime of x is the derivative of that, so it's 2 plus f of x. So this is the graph. So if I'm looking for the g prime, I'm looking for the graph, and then I need to add 2. If I look at g double prime, it's 0 plus, so it's f prime of x. So looking at the slope of the graph. Again, in prior FRQs, I talked about this relationship a lot, so make sure you really get this down, that this picture is the derivative, and then you need to use the area to figure out the function, and use the slope of it to figure out the second derivative. Okay, so now let's see. Ooh, find g of -3, g prime of x, and g prime of -3. We already kind of did half of the work, or a third of the work. So first thing, g of -3. Following the formula here, 2 times -3 plus integral between 0 and -3, f of t dt. Okay, well, 2 times -3 is -6, but this is the wrong order. We want small to big, so minus -3 to 0, f of t dt. From -3 to 0, that is a quarter circle with a radius of 3. So that is -6 minus 1/4 pi r squared. That gives me -6 minus 9 pi over 4. So that's g of -3. Okay, if we continue, g prime of x, g prime of x, we already got up here. It's a derivative of 2x, so 2 plus, plug in the f of x in there, so f of x, and the derivative of x is 1. This is that formula again. The if you're taking the derivative of the integral of a function, it's f of b minus b prime, f of b prime minus f of a prime. And so since x derivative is 1, we don't need to worry about it. And then plug in the 0, the derivative is 0, 0, so there's no second part. So g prime of 3, that's the next piece, is 2 plus f of -3. Okay, so f of -3 is 0, luckily, so my answer is 2. All right, so that's it for part A. Part B, okay, what does part B want? Determine the x-coordinate of the point at which g has an absolute maximum on the interval between -4 and 3, so between the whole thing. Justify your answer. So in order to find a maximum, you need the first derivative to equal to 0. All right, so let's take our first derivative. So g prime of x must equal to 0, which means 2 plus f of x equals 0. That means when does f of x equals -2? When does my graph equal -2? So in this picture, it equals -2 right here. Well, how do I know what that point is? Well, this is a linear function, since it's a line segment. So you could figure out the equation of that line, right? Let's see if we can find a very good point here. So we have a point here, 0, 3. We have a point here, 3, -3. So 0, 3, 3, -3. Just need to find the slope. The slope between those 2 points, y2 minus y1 over x2 minus x1. So -6 over 3, -2. Your equation is y equals -2, x plus 3, because that's your y-intercept, right? So that's your equation. So when is my equation? When is f of x equals -2? When is -2x plus 3 equal -2? Well, -2x subtract the 3 equals -5, x equals 5 over 2. So at 2.5, yeah, looks about right. It equals -2. Okay, so now what I need to do, I need to check and see if it is truly an absolute maximum, right? Because I need to check and see if the derivative before it goes up and then after it comes down, then you have a maximum. So number line wise, you have 5 over 2. So your test, g prime of, I'm going to test 0. I think 0 is an easy number. And g prime of, what's after 5 over 2? 3. Okay. Well, g prime of -3 I already got. It's a negative number. So g prime -3, we got it from part A. That's awesome. So it goes down. What about g prime of 0? Let's see what g prime of 0 is. G prime of 0 is 2 plus f of 0. What's f of 0? F of 0 is 3, so 2 plus 3 is 5. That's greater than 0. So it's up. So it does go up and down, so this is truly a maximum. So again, if you want to answer it the way that the AP test want, I suggest you look at the solution manual. It does talk about that, g prime of x is greater than 0, for x is less than 5 over 2, and then g prime of x is less than 0 for f of x is greater than 5 over 2. Kind of like the right wording for it. Okay? All right. Find part C. Find all the values of x on the interval for which g has a point of inflection. Give a reason for your answer. So, point of inflection is when my second derivative equals 0. Meaning, when is the slope of the graph equal to 0? Well, the slope of the graph is 0 is right here. This is the only place where the slope is 0, right? And the slope before that is increasing, and the slope after that is decreasing. So it went from increasing to decreasing, so it changed concavity. So that is truly a point of inflection. So I would say POI at x equals 0, and g double prime, second derivative, right? So g double prime is increasing greater than 0 for x less than 0, and g double prime is decreasing, so it went down, concave down, for x is greater than 0. So it shows you the change of the signs. Therefore, this is truly a point of inflection. Okay. Last one. Find the average rate of change of f on the interval. There is no point C for which f prime of C is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Mean value theorem for a derivative says that your instantaneous must equal to the average velocity. So instantaneous equals average. Why am I not able to find that value? Well, let's find the average rate of change first. All right, so part D. The average rate of change is going to be, it says between 4 and 3. So average rate of change says I'm looking for F. So average rate of change, that will be the final F between 3 to 4. So F of 3, F of negative 4. So y2 minus y1 over x2 minus x2 minus x1, right? So what is f of 3? F of 3 is negative 3. F of negative 4 is negative 1. So minus 1 over 7. So that gives me negative 2 over 7. All right. So it says, do I have a point which f prime of C is going to be equal to negative 2 over 7? Here's the problem. Mean value theorem only applies to continuous and differentiable function, right? Is this function continuous? Yes, it is. Is it differentiable? No, it's not differentiable here because it's a vertical tangent, and it's not differentiable here because it's a corner. So for this particular problem, the mean value theorem does not apply because this function is continuous but not differentiable. Okay, that's it.